All right, so sorry for that. So I thought we still have 20 to 10 seconds or 20 or at least 10 seconds to say goodbye. But as the time that I will say goodbye and see you guys on part 2, since we don't have enough time anymore, it already ended. Well, anyway, we'll just wait one more minute, maybe for the others, and then we'll continue our solution. So while waiting, were you guys able to follow up to this point? Equation number 4.
Sir, question, sir.
Yes?
Sir, bakit dun sa, sir, sa loop 3, yung KVL, sir, bakit minus 20? Medyo nalilito ako dun, sir.
Minus 10. Here. So it passed through this current right here. So leaving tayo, di ba? So ito yung pinalo ko lang, yung negative na sign. Kasi galing tayo sa labas, diba? One we're dealing with the loop 3 is the outer part. Okay. So ang hindi lang nasama is yung R3. But in here, everything was included. Okay. So positive, negative, positive, negative, and then going back here is equal to 0. Tama ba? Loop number 3, sinasabi mo? Or equation number 3?
Yes, sir, tama. Tama, sir.
Okay. So that is why we have negative in here. But in here, if you're going to take a look on this one, we have positive. Okay. And we're coming from here, so the leaving part is positive. So that is why we have positive I2 in here. All right. So any other question? All right. So were you guys able to follow so far? So I need your honest answer. Because if not, we can go back again from that part where you didn't understand. This is already your foundation, your very first example when it comes to solving a KCL and KVL. So it is important that you have understood everything. Sa equation 2, sir, right here, equation number 2. So let me just highlight this one. So we have KVL at loop 1, KVL at loop 2, and then KVL at loop 3. So for the loop number 1, so we are dealing with this loop. Okay. So again, we're just simply following the polarity or the signages. So we have positive 10 volts. Okay. And then the leaving part is negative. So that is why we have negative sign in here. And then how did we get this I1 and R1 right here? So this one came from the formula VIR. Okay. Since, we're talking about KVL, so we're only getting the voltages. Okay, so this is a voltage. This is again another voltage which is derived from this Ohm's law, which is I1 or I times R. Okay, and then another voltage right here, which is I3 and R3. Okay, so in here we have positive 10 volts and then negative 10. So again, we're dealing with the leaving signage. And then I1 times R1. So if we have I1, we should also get the R1. So that's rule. If you're getting the individual current and you want to get the individual voltage, so you should also get the individual resistance. So that is why we have I1 and R1 in here. And the same with I3 and R3. So we have negative sign in here leaving. So that is why we have negative in here. So negative I3 times R3. And then going back to the main source is now equal to 0. Okay, and then just substitute your corresponding given value. So R1 is 10, and then R3 is 40. So you will have this one now as your final equation number 2. Okay, so was I able to answer your question, Mr. Kabuntokan? All right, what about the others? So if you guys have already get this one, how about giving me a thumbs up? So I know that you guys were able to get uh, this solution of ours. Okay, so one, only one, 1, 2, 3, 4, 5, 6. Okay, what about the others? 7. All right. So I hope to the others who didn't respond were also able to get this one. Because if not, feel free to ask a question. Okay. And anyway, so let us now continue our discussion. So first step is KCL. Second step is getting all the KVLs from all of your loops. And then from there, you can now perform simultaneous equation. But first, before we can do, simultaneous equations, so we have to uh, make all of your variables equal to each other. So meaning, we can use maybe this I3 right here. Okay, medyo magulo na. Lalo na at thread yung ginamit ko. Okay, how about going back in here? Maybe this one is much more easier to see. Let's go here. And let me just erase this one again since we don't need that node B anymore. It's just the same with node A. So this is our equation number 1, number 2, number 3, and then number 4. Okay. And then from here, we can actually substitute, okay, or we can rewrite the equation by substituting the value of I3 onto our equation number 1 and 2. Okay. So we have 10 is equal to 10I1 plus 40. Okay. So we have I3 here before, but that one now will become I1 plus I2. So where this one came from? It came from our equation number 1. Okay. So in here, you can simplify this one a little bit more just by distributing this one, 40I1 plus 40I sub 2. So we have 2I sub 1, 40I sub 1, and then 10I sub 1. So if you're going to combine those two, it will become 50I sub 1 plus 40I sub 2. So this is now your new equation number 1. Okay. And then for the equation number 2, it's the same process. I just get everything. So 20I2 plus 40I3. But in here, you can substitute the value of I3 into I1 plus I2, which is now this one. So 40 times I1 is 40I sub 1 plus 40 times I sub 2 is 40I sub 2. And if you guys are going to calculate this one, you can actually combine the I sub 2. Okay, we have 2I sub 2, the 40I sub 2, and then 20I sub 2. So from there, you will get 60I sub 2. Okay, so this is now your new equation number 2. So from here, we can actually already solve the unknowns. Okay, so you can use these two equation. Okay, let me just write that one. So we have equation number 1, which is 10 is equal to 50 I sub 1 plus 40 I sub 2. Okay, and then for the second equation, we have 20 is equal to 40 I sub 1 plus 60 I sub 2. So what we need to do here is we need to deduct this one, okay, or deduct this one right here. So what we can do is multiply this one by, okay, wait a second. If this is 4, 8, 12, 16, 20 times 5 and then times 4. So in here, we can actually multiply this one by 4 and we can multiply this one by 5. So why are we doing this one? Because we wanted the I1 in here is equal to the I1 in here. So 4 times 50 is 200 and 5 times 40 is also 200. Okay, so you can come up with this new equation right here. So 4 times 10 is of course 40. 4 times 50 is 200 I sub 1 And then 4 times 40 is 160. 160 I sub 2. And then in here we have 5 times 20 is 100. And then 5 times 40 is 200 I sub 1. And then in here 5 times 60 is 300 plus 300 I sub 2. Okay, and then from here we can now deduct this one. Okay, well actually we can interchange those two, wherein the one that we're going to deduct is this equation number 1 right here. Okay, so 100 minus 40 is equal to 60. So 200 minus 200 is of course 0. And 300 minus 160 is 140. 140 I sub 2. And then from here, you can now solve the value of I2. So I2 is equal to 60 divided by 140. Wherein this one is equal to, just my calculator, 60 divided by 140 is 0.428 or 0.43. Okay, amps. Okay, that is already the current for the I sub 2. And then from here, you can actually use this one, okay, or you can perform again another simultaneous equations wherein the one that you need to eliminate is now the I2 for you to be able to get the I sub 1. Okay, so if you're going to do that one, okay, let me just erase this one. Let's come up to a number wherein we can make them equal. So 4, 8, 12. So this one is times 3, and then this one is times 2. Okay, so that we can eliminate I sub 2 already. So in here, 3 times 10 is 30, and then 3 times 50 is 150 I sub 1, and 3 times 40 is 120 I sub 2. Okay, this is now your new equation number 1, and then right here we have 2 times 20 is 40 is equal to 2 times 40 is 80 I sub 1 plus 120 I sub 2. Okay, so in order for us to have a positive result, well, any of those are good, but okay, let me just get this one again. Okay, so I will get this one as our first operand, and then I'll get this one as our second operand. And from here, I'll perform subtraction. So 120 minus 120 is now 0. And then 80 minus 150 is equal to negative 70 I sub 1. And then 40 minus 30 is 10. So we will have a negative I1 is equal to 10 minus negative 70 is equal to negative 0.143. We don't have enough space anymore. 0.143 amps. Okay. And then from here, you can actually already use the I1 and I2 to solve for the I3. So going back to our first equation, so I3 is equal to I1 plus I2. So I3 is equal to I1 plus I2, wherein I1 right here is 0.143 plus, this one is negative 0.143 plus, and this one is 0.43. Okay, we don't have enough space anymore. So negative 0.143 plus 0.43 is equal to 0.287. So this is now the current for your I sub 3. So from here, you already have the currents of your I sub 1, I sub 2, and I sub 3. Now, what's next? What do we need to solve more? So find the current flowing in the 40 ohm resistor R3. So here, we have already answered what is being asked. So the current that is flowing on the 40 ohms or the R3 is actually 0.287 amps. Okay, so let's verify that one. Yeah, so we are correct. So the current flowing in resistor R3 is given as negative 0.143 plus 0.429 is equal to 0.286 or 0.287 amps. So we just varied with the our decimals. But in here, we've got the correct or the same answer. Okay. And if you wanted to get the voltage across that R3, so you can use V is equal to I1 times R1 or I3 times R3 rather. So I3 is 0.286 and then R3 is 40. So the voltage that is passing through or going through that branch or path is 11.44 volts. And then in here, notice that we have a negative sign in here. So that doesn't mean that we have the wrong answer. So it's just an indicator that the direction that we have used right here, the direction that we have used in, what current is this? 0.143 is I1. I1 right here. The direction that we have used in I1 is actually the other way around. Okay. So it should be the other way around. Wherein it should be counterclockwise, not clockwise. Okay. Wherein, as you guys can see, this one is much more, larger. So of course, it will charge the 10 volts right here. Okay. So it cannot, go in clash with the voltage that is flowing here because this one is much more larger. So basically, this will just dominate the smaller voltage source. Okay. So yeah, that's how we've got this answer right here. So first is the KCL and then the KVLs. And from here, actually, you can just use two equation. Okay. We wasn't able to use the loop number 3 anymore. Well, yeah, there are some cases like that. If those two equations are right enough, then uh, it's okay. Okay, but if you need more, data, then you can use loop number 3. Okay, but in here, just by using equation number 1 and 2, we have already solved for the values of the I sub 3. Okay, so are we clear so far? Were you guys able to follow? So just give me a thumbs up if you guys were able to get this one, and just raise your hand if you wasn't able to get it. How about the others? Mr. Bradley, Mr. Jasper, Miss Maxine, Mr. Ryan, Mr. Labsan, Mr. Awas, Miss Kate, Mr. Tanikala, Mr. Kenji. I think John David already got it. Mr. Ken already got it. Hello, hello. So which part you guys were lost?
Sir, paki-explain ulit kung bakit negative yung yung I1, sir.
The I1. Yun yung lumabas lang, okay, sa result natin, okay? So, hindi natin kasalanan yun. It's just that it means that the polarity that we have assumed, okay, is incorrect. But nevertheless, same pa rin yung result, okay? It's just that the signage is different. So, if it's positive, then you will get negative 0.429 naman dito. Depende kasi lagi yun sa signages natin, ito, sa mga leaving and entering signage. So if you're using entering signages, then you must stick with that. The same with the loop number 2 and then loop number 3. Okay, you cannot have a different method in here and then another method in here and then another method in here. So just be consistent, okay, to avoid having a different answer. Having a different sign is okay, but having a different answer is, of course, it's not okay. Okay. So again, in here, if you have negative sign, just that the mean that direction that you're using is incorrect. Okay. So should be the other way around. So okay lang kahit ano yung polarity na gamitin nyo. Same pa rin yung result. Maybe yung sign lang yung magbabago, pero correct pa rin yan. Alright? So maybe one thing to, to prove that one. So instead of using the leaving signage, maybe you can use the entering signage. Okay, so instead of positive, you can use negative, and then in here is positive and then positive. So the same with this one. So in that way, maybe you will come up, and also you can change the polarity, okay, of your flow of current in here. So instead of having a conventional, you can go electro method, okay, electron method. All right. So was I able to answer your question, Mr. Lawrence?
Yeah, thank you, sir. Gets it.
Okay, so okay lang kahit negative or positive. Same lang yun. Any other concerns? Right, so maybe none anymore. So let's now proceed to the next one. Okay, so in here, here's the summary on how to use the KCL. Okay, or the how to apply KCL. So these two laws enable the currents and voltages in circuit to be found. For example, the circuit is said to be analyzed, and the basic procedure for using KCL or Kirchhoff circuit laws is as follows. So first, you have to label everything first, like what we did a while ago. So we put our signages, positive, negative, and then the flow of current, and then your assume ano ba tawag dito? Assume flow of current or assume a method to be exact. So in here, we've used conventional method. And then in here, we've used uh, electron method. Okay, or the counterclockwise. Then after that, you can now proceed to step number 3. Okay, so labeling each branch with a branch current. Let's say this is your I1, this is your I2, and then this is your I3. It's just that in this given example, the labels for I1, I2, and I3 is already given. But usually, when it comes to real exercises, the flow of currents is not given. You're the one who's going to assume the flow of current. Okay, so is it clockwise? Is it counterclockwise? Is it going from here to there? And so on and so forth. Okay, just be consistent with your signages and then with your method. And then here you can now find the KCL, just like what we did a while ago. There's one right here, the KCL for the equation, for the node A. And then next one is the KVL, okay, which what we did for the KVL loop 1, loop 2, and then loop 3, right? And then from there, you can now use linear simultaneous equations as required to find the unknown currents. Okay, so in here, we actually have two ways to solve, how to solve the unknowns. Okay, as long as you have the same variable names, like for example, right here, you can already use this one, okay, without multiplying that one by 3 or by 2. Just by having these two equation number 1 and 2, and then they have the same variables, let's say I1 and I1, I2 and I2. You can use your calculator. Okay, so I would like you guys to grab your calculator, and then I'll teach you on how to use simultaneous equation using your calculator. So you don't need to go over, having this kind of solution and then this solution, and then just to come up with this I1 and then this I2 right here, and then come up with I3. So from here, you can already solve the value of I1 and I2 just by using your calculator. So in my case, just go to setup, and then find the equation. So in my case, it's under letter A because I'm using FX991EX class Wiz. So that depends on your calculator, but in my case, equation is on the setup and then letter A. Okay, and then it will let me choose between simul equation or polynomial. So the one that you need to choose is of course the simul equation. Okay, so number one, and then the second thing that it will ask you is simul equation of number of unknowns. So in here we only have two unknowns, I1 and I2. So I'll go with 2, and then from here it will also already give you this kind of equation. So paano ba? How will I show that on you? Maybe you can just search the internet. Alright, so do you guys have this calculator with you? Or a different one? What are the versions of your calculator? Because if you have this kind of a version, then this is the one that you should be watching. If you have this kind of calculator or version of calculator, then this is the one that you should watch. Well, anyway, let's just go over with this kind of calculator, FX991ES. Mine is EX, so this one is different. So this is actually the calculator that I used when I was still in college. So this is just an example. We have, two unknowns, X and Y. And then how will you solve that one using a calculator? So just go to mode and go to number 5 or EQN or equation. Okay, 5. And then from here you can choose from 1, 2, 3, and 4. So the first one is two unknowns. The third one is, let me just go back to the mode A. Okay, so 2, 3, 4. Well, this one is quite confusing. But the first one is two unknowns. The second one is three unknowns. And the third one is maybe another kind of equation. Okay, so from here, just choose two unknowns. And then it will give you that kind of equation. I mean table or array. So just put the, the proper arrangement. Okay, so X first, followed by the Y, and then the last one is the voltage or the equated value, okay, which is 26. Okay, so 3, 7, 26, and then 4, 5, and then 13. And then from there, it will already solve the value of your X and Y. Okay, that's how easy it is. All right, so in my case, I just put this one, so 50, and then 40, and then 10, and then 40, and then 60, and then 20. So from here, I've got a result of negative 0.14 for the I sub 1, negative 0.14, this one. Okay, this is negative. And then if I click equals one more time, then it will give me the result of 0.42 or 0.43 for the I2. And then from here, you can already solve for the value of your I sub 3 since you already have the I1 and I2. Okay. So, are you guys able to follow so far? Have you guys already explored your calculator and how to solve simultaneous equation? Anyone who was able to follow? Or none? Sir Mina? Sir Jasper? Miss Abigail? Sir Ryan? Sir Labsan? Only one?
Wala
Sir
akong calculator, sir.
Jan?
Wala akong calculator.
Paano yan? What if sobrang lalaki ng mga values? So you'll be needing a scientific calculator, okay, to make your work easier. Or you can use the calculator of your smartphone or laptop, but it's much more difficult. Anyway, so yeah, that's how you solve the values of unknowns using a calculator. All right. So in here, as well as using KCL to calculate the various voltages and currents. All right. So just another explanation when it comes to KCL. All right. Again, another explanation. So I will not go over with that one anymore. So in here we have Kirchhoff's current law, example number 2. So we have I1, I2, I3, I4, and I5. Okay. So the question here is solve for the individual currents. Where is that one? Okay. So in here we need to solve for the individual currents that is flowing on each resistor. So we have R1 up to R5. Okay. So in here, I recommend you guys to do this one on the actual paper, okay, for you to be able to appreciate it more and to understand it more than just by reading and following what we have here in the PDF. Anyway, so we have 132 volts for the voltage source, and then we have those given values in here. And the first thing that you need to do is, find the voltage that is flowing onto this I1 and I2, and then I3 and I4 and I5. So in here, you could say that, you already know that we have the same voltage flowing on the I1 and I2, okay? And the same with the I3, I4, and I5. So that's the rule for the parallel when it comes to getting the voltage when it comes to parallel. So they are just the same for this one, I3, I4, and then I5. So that is why in here we can just simply get the total resistance of this I1 and I2, and then the total resistance for the RCF, okay, right here from C to F. And then from there, we can already combine the total current, and then we can now get for the total current. I mean, total resistance right here. Okay, so 1 ohm for this part, and then 10 ohms, 11 ohms rather. No, sorry, 10 ohms only. Okay, for the RCF. And then for the total current, so we have 1 plus 10 is equal to 11. So from here, we can now get the total current. Okay, so IT is equal to V divided by RT. So your voltage source is 132, and then your total resistance is 11. So just do the math, and then you will get 12 amps. And then from there, you can now, what's next? Equivalent. Okay, so this is just an equivalent value when you simplify that one into RAC, and then RCF, and then the total current. Okay, which is 12 amps. And then from here, you can now solve for the individual voltages of those RAC and then RCF. So for the VAC and for the VAC only, okay, so we have I total times RAC. Okay, so RAC is 1 ohm, so 12 times 1 is 12 volts. So from here, we could already say that the voltage that is flowing on the I2 and I1 is 12 volts. Okay, and then for the VCF, okay, so just use the current for that one, which is 10 volts. So I total is still 12 volts, of course. So 12 times 10 is equal to 120 volts. Okay, so we could already say that in this path right here, so we have 120, another 120, and then another 120. So since we already know the voltage that is flowing on those paths, so we can solve for the individual currents. So we can use this formula. I1 is equal to VAC divided by R1. So VAC is equal to 12, okay? And then just put the individual resistance. So R1 is 2.4, and then R2 is 1.7. So 5 amps for the I1, and then 7 amps for the I2, okay? So 5 amps right here, and then 7 amps for the I sub 2. So notice that right here, so once I1 and I2 combine, Okay, so it is now again total to IT. So that is why if you combine 5 plus 7, it will give you again another 12 amps. Okay, which is the same with our total current. Okay, and then for the I3, I4, and then I5, so the one that we're going to use as our voltage is of course the one that we have solved, which is 120 volts. So 120, 120, 120, and then just substitute the corresponding resistance. So we have 60 for the R3, 20 for the R4, and then 30 for the R5. And then just do the math, and then you will get 2 amps for the I3, 6 amps for the I4, and then 4 amps for the I5. And then notice that if you're going to add those three, it will give you again the total current or the value of 12 amps. Okay, so that's how you will check if you were able to get the correct answer or no. So if it's not equal to I total, then maybe you're getting the incorrect answer or the wrong answer. But if you're getting the total current, okay, if you add those resistors, then you're now, let's say, 90 to 95% sure that your answer is correct. Okay, so yeah, that's how we've got those individual currents. So this is just with the use of Ohm's law. Now, to verify that one using a KCL, okay, so we have this one, I total is equal to I1 plus I2 is equal to I3 plus I4 plus I5. So again, going in is positive and then going out is negative. So if you're going to have a KCL at this node right here, so we have I1 and I2 going in, and then I total is going out. So from here, we can already verify that your I1 or the values of your I1 and I2 is really, really correct. Okay. So the same with the I3, I4, and then I5. So we have, let's say, a node in here or a node in here. So either of those two, C or F. So let's just use C since it's much more nearer than the F in here with the IT. So IT is going in, and then I3, and then I4, and I5 is going out. Okay. So from there, you can already verify that your I3 and I4 is really correct when it comes to the total current. Okay. So yeah, you can use both method, Ohm's law, KCL, and KVL, to compare, and then, to check if you've got the same answer or no. So, were you guys able to follow up to this point?
Medyo, sir.
Medyo. Anyway, this is just, let's say an example, if you're going to use Ohm's law, and then if you're going to check it with the use of KCL. Okay, so you can always, go back here from the very start and then start reading, and then how did we get this RAC, RCF, and then I total. So yeah, just read back again. Okay, since we cannot last or you cannot stay here for 10 to 30 minutes just for this example, since it's not really part of the KCL or KBL. Anyway, so again, we don't have enough time anymore, so we'll just continue the rest on the part 3. Okay.